All righty. Thank you very much for joining us this evening. My name is Ian Capizzoli. I'm one of the admissions counselors here at WPI, and thank you very much for coming to this physics session tonight. We are joined, of course, by Professor Petke and one of our students, Patrick Mullen. So for a quick bit of housekeeping before I get out of the way here, this is a webinar style format. So if you folks have any questions throughout the information session, just use that Q&A feature, which should be at the bottom or the top of your screen, and we'll have time at the end to get all those questions answered. So without further ado, I will pass it over to you guys.
Thank you. And again, welcome to the session on physics, and I will go ahead and share my screen. Uh-oh, Ian, I don't think I can share my screen.
I think it just made you co-host, so try now.
Okay, super. All right. And then Patrick, can you see that okay? Great, thank you.
Yep.
Super, thanks. So welcome. So I'm Doug Petke, Department Head of Physics, and then Patrick's is a physics student who's gonna be around to answer some questions sort of towards the end. And so welcome, congratulations. So you have a decision to make on where to go, and we hope this webinar helps you with that decision. And we of course think WPI is a wonderful place, and so we hope you choose WPI. I'm going to go over sort of a grand overview of physics. It'll probably take about 15 minutes or so, and then we'll have the chat open for questions and answers. So there's physics, like a lot of other disciplines, is a fundamental approach to problem solving, right? And so the world is very messy. We have different approaches to solving problems. And one of the things we actually like to focus on is asking important questions and discovering solutions rather than trying to find an answer. And so there's a finite number of majors in each university and each that you can sign up for, but there's sort of an infinite number of problems and needs and needs in the world that you're going to have to solve. And so physics is a very good fundamental one to approach problem solving from. And so we also solve puzzles in the sense that we don't quite know how things are working. And we want to, again, seek those solutions. And that's also the basis for all of science and engineering. And as I'll describe towards the end, there's a lot of different career pathways from teaching to graduate school to directly entering the workforce. And so there's a lot of doors open in a physics degree. To show you a few things that some of my favorite types of research going on in the department that students can be involved in or will be involved in through the project-based learning that we have, is this one is something called active matter. And so it's showing a bacteria-powered gear on the left-hand side. And you can see the scale of this is sort of on the order of 400 micrometers. And there's a tendency for the gear to spin in one direction, which is what you would want to do with any type of motor. And so this is, and then over on the right side is a blown up image of particle tracking that Professor Wu uses in his research lab to try to come up ways to control biological processes that would essentially be converted into mechanical energy, and hence the word active matter. And so it's an area of biophysics that we have a focus on here. And so I just continuously get fascinated by going down to these smaller scales and fundamentally looking from a physicist's viewpoint on how nature works, even in the areas of biophysics. So what do we do at WPI with our programs? And so we really have an emphasis on working closely with students on co-discovery, co-creation, co-engagement, and authentic experiences and connections together. And so this is sort of the diagram in the center is what faculty and students do at WPI in most places. So there's fundamental research in some of our research labs. And there's a nice picture of Patrick when he was actually a sophomore working in the labs. There's education. And so we have active learning spaces where we have TAs and PLAs that wander the room and students are working on problems together So rather than just listening to lectures, we actually do stuff in the classrooms. We also have a teacher preparation program, and I'll play this video that I think will translate okay. 2, 1. And so it's obviously showing a principle of inertia, and this is where the physics teachers get together with both in-service teachers and teachers in our program on something called the Teacher Advisory Group on Saturday mornings to share demos and inspiration. The bottom center is a industrial student meeting where there's people from the photonics industry, and students are getting up to share what projects they've been working on. So this is Optical Society of America regional community, and then community meeting. And then on the lower left is outreach and service, where we have students and faculty participate in something called Touch Tomorrow, which just happened actually the other day down at Polar Park, where we engage the community in some of the wonderful things we're doing. And this is actually a Professor Wu's demonstration on active matter that he has going on in the background, where he sort of macroscopically describes what some of his research is at the microscopic level. Oops. So you've probably heard a little bit about the WPI plan, and we like to re-emphasize it and how it's connected to physics. And so the WPI plan includes a lot of project-based learning. And so we have in the first year, the Great Problem Seminar. In the second year, Humanities and Arts. In the third year, the Interactive Qualifying Project, which is our signature program. And in the fourth year, the Major Qualifying Project, which is typically a year-long senior project that students participate in. And to give some examples for each of these, again, I have these listed here, and faculty also in the physics department also help lead some of these projects. So for instance, this is from the poster session in the first year seminar. And in the Great Problem Seminar, Dave Medich, who works in nuclear science and engineering, helps co-teach a session on Power of the World. The other projects I have examples of. The Humanities and Arts, which consists of a very deep dive into a specific area, typically during your sophomore year, has students working with faculty in the Humanities and Arts on projects of deep interest to them. And there's also prizes each year. And so in this case, the prize was awarded to Aviv Brest and Aaron Morissette. So 2 physics majors tied for the top prize in the entire class. And so I like to emphasize that. And Aviv studied the ethical framework for genetic engineering of animals with a philosopher. And Aaron Morissette studied the acoustics of the clarinet and Spalding recital hall with a musician. And so these aren't just typical buffet general education courses at most schools. You actually get very deep and meaningful experiences in the Humanities and Arts projects. The IQP, and you've probably seen some information on this, but we have over 50 project centers on 6 continents, and we send groups of about 24 or 25 students along with 2 faculty to these project sites to couple to the stakeholders at those sites to solve problems of significant interest and meaning to them. And so you really get to understand what the problems are in the world, and in an interdisciplinary manner with your fellow students from all different majors, work on solving those problems for the stakeholders. I'll come back to that one. In terms of the IQPs, we have Professor Nancy Burnham that runs the Switzerland Site Center. And so she sets up the types of projects with the stakeholders at Switzerland, and also sets up a few senior projects that can be done over there as well. And so we have physics also leading the effort to establish different IQP sites. And when students go away to one of these, I'm going to back up to this other slide. And this is sort of a hypothetical 4-year degree program to show you a little bit about how the project-based learning works and how our academic calendar works. And so typically we take a full semester and divide it into two, and we take near semester equivalent courses in each term. And each term is 7 weeks long. So here is Physics 1, Calculus 1, and a Great Problem Seminar, followed by sort of Physics 2, Calc 2, and the Great Problem Seminar here. So that's the normal pace, is 7-week courses and 4 of those in a year. But then when you get to being able to go to one of the IQP sites around the world, that's when you prepare for the site by taking a course called ID 2050 that preps you, picks out your project, and prepares you for the cultural that you'll be in and the stakeholders that you'll be working with. And then you go to the IQP site full time. And so, and then notice this is still a 4-year degree. And so you can travel abroad by going to the sites for the whole term. And that takes about 2 months to complete. And at the end, there's you provide a deliverable to the stakeholders at that, and trying to push forward and solve the problems of interest to them. And so that's a little bit about our calendar that lets us do unique things, like even co-oping, where you would spend full time on a co-op and then turn that, couple that to an internship over the summer. And so our calendar is really unique and lets us be flexible on when students go to their IQP site or do other kinds of project-based learning without sacrificing time to degree, like some other places. Right, so that's a broad overview on how physics fits into some of the project-based learning WPI wide. And then within the physics department, we have 20, we graduate about 20 students a year. It's actually getting closer to 25 and about 100 total students. 20 full-time faculty with 2 staff and administrative assistants. We have also PhD programs, master's and PhD programs, and so we have about 25 PhD students. We also have a peer learning assistant program that helps students decide whether or not they would like to teach as a career. And you take a pedagogy course to learn how to become a learning assistant, and then you help to deliver some of the courses. And in one of those earlier slides, there was a peer learning assistant walking around the classroom with the faculty members, assisting in studying the topic of the day. We have several research labs. We focus on, as I mentioned before, biophysics or soft matter, so the squishy stuff. Non-squishy stuff would be condensed matter or nanoscience, and so working with the really small. We also have photonics is a core area, as well as electromagnetics. We have, in terms of research buildings, most of us are housed in Olin Hall, and so a lot of buildings have most of the disciplines in one spot. We also have some people down at Gateway Park where some of the newer labs are. And then later on, you'll see a few pictures of some from our physics lounge where a lot of people hang out. And in this case, you can see some students working with Professor Chitova in the laser lab and with Professor Medic in the nuclear science lab. We have several different programs. So we have the physics program, the applied physics program. They're slightly different. The applied physics would have you focus on, have 6 courses focused on a particular theme. And in each one of these majors, there's 15 core courses to take. We also have the teacher preparation program that provides you with a bachelor's of science in physics. So it would be the physics major as well as an initial licensure in teaching high school physics. And we have a lot of double majors. The most popular ones are mathematics and mechanical engineering, but there's one of just about every major in the department. And about 10 or 15% of the students do a double major. We do have a BSMS program that's accelerated, where you can double count some of the courses in your senior year. And we have astrophysics, nanoscience, sets of courses that are concentrations. We do have a lot of math courses in our curriculum. So that's sort of, we think of that as setting the grammar, and then physics is the interesting story in the literature. And so there's 9 courses and then 15 physics courses. So you can see there's quite a balance with a lot of math courses in addition to the physics courses. Within physics, we have 5 principal areas. And then we also have a flexible curriculum where you can take 6 other courses that are essentially anything that WPI offers. The 5 principal areas are mechanics, electromagnetism, experimental physics, quantum physics, and statistical and thermal physics. And so those are the 5 core areas within physics itself that provide its own foundation to study other things. And then those other things, we have quite a few other elective courses within the program, such as nuclear physics, solid state physics. And then I pulled out an option out of the catalog just to show you the variety, but then also the focus that you can have. And so in this case, there's, if you're interested in optics and photonics, which is also strong in the New England area, we have photonics, lasers, and optics courses, and even a photonics lab that's not even listed. And then likewise, we have other areas where we have atomic force microscopy and other types of specialized courses that students can take. Whenever there's a course that's sort of driven by demand, we have independent study units that complement our formal offerings. And so that's most recently been things like general relativity or courses like that. And I think there's going to be one in particle physics coming up. So career pathways, back to what do our graduates do? And so again, there's a lot of different options. About 50% of physics majors go directly to employment. And these are actually national trends, and we follow the national trends rather closely. About 30% go to physics and astronomy graduate school, and about another 20% go to other fields like engineering, or in some cases law or medicine, in terms of graduate school. And so about half directly get a job and half go to graduate school. This is some data that was initially gathered in 2013 to 16, and we've been slowly updating as students graduate. And so a list of graduate schools is shown on the left. And so you can see it's predominantly a lot of people stay in the New England area. Employers are shown here, and there's a wide range of different types of employment. I think a student just was saying today that they're going to go work for MathWorks, which is a software company that does sort of advanced programming, and they make the program called MATLAB, but they do a lot of other things as well. Some double majors are shown here. So these are the ones I add to this list as we find the double majors, and so there's quite a few different double majors that are in with physics. And there's ways to leverage the double major where you do some double counting of the degree requirements. And then we also have a very good career development center. Its sort of acronym is unfortunately the CDC, which is obviously in the news a lot these days. But this is the Career Development Center, and they have a great system for matching both interns and jobs with our students. And we refer, whenever I talk to employers looking to establish relationships, I always point them to our Career Development Center as one of the conduits. Physics teaching as a profession, we have a heavy emphasis on this because if you come down to the lower left, there's a severe teacher shortage, and 5 is the most severe, and physics is at 4.53, followed behind with math and chemistry. And so to have a strong STEM nation, we need strong STEM teachers. And so we're trying to address this considerable shortage. And there's also a lot of myths about teaching always not being portrayed as a great profession that it is. And so the mid-career teacher salary after about 10 years is well into the 75 to 80K on a 9-month contract. The retirement benefits are great. We're retiring at a significant fraction of your pay. And then 78% of teachers are still teaching in year 5, so they do not leave in droves. And maybe the more important thing is the intellectual challenge and satisfaction is rated equal or higher than private sector STEM careers. And typically teaching is just below the medical doctor field in career satisfaction. And so we have a pretty significant, we don't have an education school, so we house our physics teacher prep program is in physics and in collaboration with the STEM Education Center, including some nice grants, the Noise Teacher Scholarship Program that we were just awarded last year that pays up to $20,000 a year for 2 years to undergraduates to be in that program and enter in a urban school district for teaching, which would be right next to WPI. Student chapters, we have engagement of students in a lot of activities. So there's both professional societies, so Optical Society of America, the Materials Research Society. We also have a very active Society of Physics students and just formed a Women in Physics club. And this is during project presentation day where it's in our physics lounge following the day of, and it's usually in late April, where all of the students present their projects and then we get together for sort of a celebration luncheon and award ceremony. And then this is showing the Society of Physics students chapter meeting in the lounge, which gives a different perspective and where the students are just talking about different aspects. And I think this topic was actually how to engage in research as early as possible. And then the sampling of the senior projects. So these, and you start taking a look at these titles and you say, how will I ever be able to present anything like this? And so this is the great thing about 4 years from now, where you'll find yourself understanding it is whatever topic it is that you're presenting, regardless of how daunting it might seem right now. But there's some pretty cool projects. In some cases, a lot of students will work with faculty in their laboratory. And so this is looking at nanomaterials and what happens in making two-dimensional nanomaterials, sheets of material. And then in some cases, the projects will be sponsored by external sponsors like MIT Lincoln Lab, where they were looking at propulsion systems for satellites. And so in a lot of cases, students will work closely with faculty and other students in the labs. And those are usually, as opposed to the IQP project, the MQP is usually spread out over the whole year. And this year, students are already getting ready for their MQPs for the senior year by doing some stuff in the spring, so they get a good head start. And then that was the formal presentation. So I wanted to take any questions in the chat. And of course, I'm also going to be available by email. Let me go back up to the beginning. So my email address is down at the bottom. And you can find me on the webpage. And then what I will do is stop sharing. And then Patrick's here. I'll have Patrick pick a topic or two to talk about. And then we'll go to the questions and answers.
So
I think I stopped sharing, right?
Yep. So yeah, hi everybody, I'm Patrick. I'm a senior at WPI. I major in physics and computer science. Some of the stuff I figured I'd share with you all today is a little bit about some of the projects and research at WPI, specifically like how the physics major and the physics department helps prepare you for those things. And I can also talk a little bit about some of the fun activities that I'm involved in while I'm here also. So in my experience, you know, getting interested in getting involved in research was very, very easy for me. I was able to approach Dr. Pecky after one of my lectures with him, having not spoken to him prior, and said, hey, I want to get involved in research. And he immediately got me into his lab to work. So, and there are similar experiences from other students who approach other professors saying, hey, I'm interested in this topic. I'd like to learn more about it. And, you know, within a little while, they have some sort of opportunity to get involved in some sort of research. Additionally, you know, I've done various kinds of research that I feel like the physics degree has sort of prepared me to take on. So in my sophomore year, I also spent a fair amount of time doing some history research in the library archives, and a lot of sort of the organization problem solving skills that you picked up in in just the major or in the field of just trying to do physics has actually kind of helped, as well as contextualize some of the research that I was doing, because the research was involving STEM education, specifically WPI's plan from 1970 to currently. And then that also really helped me when it came to my inquiry seminar in my sophomore year, where I did global environmental policy. My junior year, I did not get to go abroad for IQT because COVID happened, but instead I was able to stay in Worcester and get involved with the Massachusetts Alliance Against Predatory Lending. They wanted us to build them a database software application where they could store records of foreclosure data. So we built the database and we collected foreclosure records from all around the state from 2000-ish to relatively present day. And the intent would be that the database would be used for legal analysts and policy experts to try to actually catch cases of predatory lending and try to get people their homes back. And then this year, I was able to spend a lot of time with my MQP in a more theoretical area of physics concerning Hawking radiation and considering black holes, specifically one with a given mass, angular momentum, and an electric charge, and sort of calculate the thermodynamic properties of that. So that's sort of been the various different things that I've been able to do that I feel like my time in the physics department and in this major sort of prepared me for to take on that type of research and to think a little bit outside the box. And then to briefly just touch on some of the other stuff, like clubs, like I'm involved in SPS, which is run by a couple friends of mine, Morgan, Will, a couple other people who are now the new executive board. And they meet weekly, do a lot of really fun stuff. They will talk about course scheduling. There's meetings just to discuss, like, hey, when we're going for registration, what class should I take, when, how, and how do I organize this? So there's a lot of the support network built there. Additionally, you'll find a lot of us in the lounge, but there's also times where we just play like fun games or activities and things like that. So yeah.
Great, thanks, Patrick. So I think we will just stop here and see if there's any questions that you can enter into the chat.
And Patrick, I will. You might have touched on this a little bit, but I'll get us sort of kicked off here. Biggest question that we'll always hear on tours and such is just, why did you choose WPI? And then maybe if you can relate that back to physics at all, did that have anything to do with it?
Yeah. So I chose WPI for a couple of reasons. I really liked the quarter system. I really liked the project-based learning primarily. Those were the big things that really stuck out to me. Additionally, I also liked that WPI was not very strict, and especially the physics department is also not very strict in terms of like holding you to a prerequisite. They sort of trust you with your own education and your own understanding of your learning and yourself to take a class that could be harder. Like I've had friends that, did not take undergraduate quantum and just went right to graduate quantum and they did well. So I think a lot of the freedom of choice and flexibility provided by both like the physics department as well as the administration and how they run classes and things like that was really attractive to me coming into WPI, because I felt like I would get a good grasp on the direction of my education. Especially doing a double major, I needed that kind of freedom also.
Yeah, definitely. And as far as, doing your double major, how did you kind of work all of that out? Did you do overloading a lot? Did you take some summer classes? How did that work out for you?
Both. I overloaded far more than I had to, but that's on my fault. And it primarily came down to, I saw a class that looked cool and I said, well, I can overload. And then you don't have to do that as often as I did. I did take some summer courses. I did overload quite frequently. I wouldn't say that is a requirement or if that's normal. It's just a habit I have.
Mm-hmm. Gotcha. Awesome. All right. So it looks like we got our first question here. So I guess this one's aimed for you, Patrick. So did you know that you wanted to major in physics when you were going into WPI? And the person who's asking says they've taken physics 1 and 2 in high school, love the classes, but that's really all they're going off of, for making that major decision.
Right. Yeah, I mean, I did know I wanted to major in physics also in computer science before I came into college. I think if you're asking about like the motivations as to like why I wanted to, I always really found physics in terms of like space and astrophysics and some of the more theoretical topics to be really interesting. And so getting to the point where like I am right now with my thesis, actually being able to spend time like explore black hole thermodynamics has been really, really exciting. And it's sort of a fulfillment of what I wanted to do when I came into physics. But there are a lot of students that I know at least who have come into physics at WPI just because they liked taking physics in high school. And they very quickly found stuff that interests them at the department. So yeah, I think that was sort of my motivation, but also if I understand correctly, the student has the motivation of I just like the classes, and that is a very valid one also, in my opinion.
Yeah, and I mean, one thing I'll add on to that too is that if you do come into the institution, you technically don't have to lock down a major field until December of your first year with us. And then after that, it is also really easy to change your major at any point. We never make students like reapply to a certain school or anything like that within the institution. We just make you fill out a little bit of paperwork basically, and then you're good to go. So we like to try to maintain that flexibility that you mentioned. So we'll give you guys the chance to ask any more questions that anyone has here. Now is definitely the time. One other thing that I'll mention as well, I know Professor Petke, you put your email address up, I think a little bit earlier, but if you folks have questions for other students or anything like that, you can also send them to the admissions office. We've got a lot of tour guides who work with us, and we can of course send them to those folks, but of course any faculty members or anything like that as well, we can absolutely get those questions answered too. But again, feel free to use that Q&A feature. All right, so next question here. I'm assuming again, aimed towards Patrick. So how would you describe the academic enthusiasm of your peers?
That's actually a really good question. Let me think about. I think it will definitely vary in terms of what the enthusiasm is, like depending on what grade you are, because when you're a freshman, you get really excited about like all your different classes. I think the further down you go, you get more excited about like I'm doing this in my major, I'm doing this project right now. I think that WPI has tried very hard, especially even with COVID, to try to make sure students have something to feel excited about. Like for example, my peers who are in my own graduating class working on their MQPs seem to have really enjoyed their experiences currently with it, the types of research that they're doing. Some of them are going into jobs in that field, be it in research like R&D or like technical liaisons or something like that. So I think that there's a whole lot of enthusiasm about the projects especially, and I think that another thing that I didn't quite get to touch on was when there's not like a class that's offered, you can also work towards like getting an ISP set up. So students will get very enthusiastic about setting up a class that's not necessarily offered traditionally, but they can get their friends enrolled into. So this year I did, me and several friends were very happy to have had a general relativity course run this fall. And we all very much enjoyed that. So I would say that people are very interested in what they're doing, very passionate about what they're doing, and they're having a good time.
Cool. All right, awesome. So we'll give it a couple more minutes here for any other questions that come in. In the meantime, Patrick, I'll ask you, what has been your favorite project so far that you've worked on at WPI?
I liked them all for very different reasons. So I'm actually a terrible person to ask what's your favorite X, Y, or Z, because I tend to be very conservative with what I lump into the same category of thing. But I mean, in terms of like physics related topics, I very much enjoyed the MQP, specifically like the more theoretical, challenging aspect of it. And then from the more humanities aspect of it, I'd have to say between like maybe the inquiry seminar and the IQP were very similar in that camp. I liked the IQP quite a lot because I felt like our work was really, really impactful. We were working in an effort with a massive organization of volunteers, as well as legal analysts and experts, to try to get people their homes back for the first time, possibly in like 20 years, which is, it felt like we were actually doing something. So that was almost an entirely different feeling that I couldn't even quite compare to doing like just general academic research. So that was also incredibly exciting and rewarding. So I'd probably say I have to put it at like a tie between those two for the reasons that they were so different.
Mm-hmm. Absolutely. And I also don't know if you touched on this, but looping it back to Professor Petke, you mentioned the students who were involved in the humanities as well. So Patrick, what did you do for your humanities at WPI?
Primarily, I did the depth. My depth was in history. My breadth was in international studies, and then my capstone covered international climate policy. And so this happened around the time that COVID hit, and so I talked about specifically how some of the socioeconomic, political issues of the time were quite similar to some events that we saw in the early to mid 20th century. And how certain types of policies and interventions could actually ease both the pains of COVID and climate change simultaneously. And that was sort of what I spent those 7 weeks exploring in my capstone.
Awesome. Wow, really cool. All right, so next question came in here. So for Professor Petke, how is undergrad student available? How is undergrad student research available for physics students, and what's it like to get into academia as a future career? So, student who's graduated college and starting their academic career.
Yeah, good questions. Like Patrick said, I think the barriers are pretty low to get into research in one way or another. And so typically when students ask me, I usually put them in my research lab. Now, it's not that every student asks me that. If every student asked me that, I'd probably have to start making some kind of choices. But I think that sort of meets the students where they're at. Some people are ready to get into the lab in their first year. Other people are growing and developing in different ways on campus with club activities, and maybe not quite sure what major it is that you want to be at. And so when students simply approach me, my approach is then to have a discussion with what interests them. Is it computational? Is it experimental? What are some possible career goals? I don't necessarily expect people to know that at any stage. Sometimes, right? That's usually pretty open. And then we try to identify some projects that maybe students can start working on. And those can be those independent study units for class. It can be volunteer. In other cases, we have external funding for projects where I absolutely need students to just help me get some research done. In that case, I hire them, and then there's a little bit of a deliverable with research projects. I'm trying to get something done. And then going into academia. So that's I'm trying to think of the statistics for this. I think it's one in, for physics majors, it's actually kind of high, the fraction of undergraduate students that become professors compared to any other major. But I think it's something like, I'm trying to think of the numbers. I'm probably going to, the thing is I have two different numbers in my head and they're drastically different. There's a 1 in 20 and a 1 in 5. So I think it's somewhere between that, the odds of becoming a professor having an undergraduate degree in physics. Seems like it should be 1 in 20, but for some reason I was thinking it was higher. And those are, at each level, it becomes more competitive. So one, there's getting into graduate school in physics, which about half in those national statistics, about a third of our students nationally go to get a PhD in physics. And then there's some fraction. So let's see, I'm doing the math now. So 1/3 of the undergraduates go to graduate school for physics. And then I would say maybe about 1/5 of those that graduate with a PhD probably go into academia. So that's the 1/15th number that I think I was searching for. And so that's about it's easiest to do national averages and stuff like that, but it really depends on the types of things you're interested in. And there's a lot of, there's going to a huge research institute. So those are called R1s, where you're expected to generate a lot of funding, external funding. So it's almost like a startup company. You have to write proposals, do research that people find valuable. But then there's places, WPI does a wonderful job of both paying excellent attention to teaching and balancing that with research. And so we're called an R2, where we do have significant research thrust, but we also continue our focus on working closely with the students in courses. And then below that, there's a lot of schools that, where you're not expected to get research money and you just focus on teaching and doing projects with students. And so there's a wide variety. And so it somewhat depends on what your goal would be in terms of teaching. If the goal is to teach, or if the goal is to be a professor that, led a large research group and sought external funding. So.
Awesome. Thank you for that, Professor Pecky. So it looks like we have just about 1 more minute here. So feel free to send in any questions that you folks have. Again, I'm actually going to just leave our email address in the chat, and also feel free to do so as well if you guys would like. So again, if anybody has any questions, you can definitely reach out to us there, and we'll be sure to answer this as best as we can. But if not, I think it's about time to wrap it up here. So thank you folks for joining us tonight. This session was recorded and will be available on the Admissions YouTube channel as well. So you can feel free to check it out there if you want to recap anything. And then otherwise, Professor Pecky, Patrick, thank you very much for joining us as well. And for those who joined us as viewers, hopefully we'll get to see you guys on campus sometime soon.
Thanks, everyone.
Right.
Take care.
Thank you both.
Great.